It happened 66 million years ago. Hey, it could have been September. A massive asteroid slammed into Earth, bringing along chaos and devastation. The tragic aftermath of the terrifying collision led to the extinction of dinosaurs. Yes, I'm talking about the Chicxulub asteroid that left a massive crater in Mexico and changed life on Earth forever. And now, it turns out it wasn't the only cosmic rock to hit our planet during that time. Scientists have just confirmed there was another asteroid. This second space rock wasn't as big as Chicxulub, but it still packed a punch. It crashed to the ground off the coast of West Africa, smashing into the ocean and leaving a crater called the Nader crater. And tell you what, it wasn't a small splash. The impact was so powerful, it triggered a whole tsunami. It was more than 2,600 feet high, almost as high as the Burj Khalifa, the tallest man-made structure in the world. But how did we come to the conclusion that there was a second impact? Well, this researcher spotted the Nader crater in 2022. Dr. Nicholson was looking for some high-tech scans of the ocean floor when he noticed a massive 5.5-mile-wide depression under almost 1,000 feet of water. Well, he thought it could be an asteroid impact crater, but at the time, the evidence he had wasn't solid. But now, scientists have confirmed that this is the real deal. A second asteroid did hit Earth during the dinosaur extinction era. Now, let's see how they figured all this out. For one thing, there were those super high-resolution 3D seismic images. They allowed researchers to peel back layers of the ocean floor and get a crystal-clear look at the crater. It was like going from a blurry old ultrasound to the kind of 3D scans where you can see every little feature. Their findings confirm that the crater was left by an asteroid, somewhere between 1,500 to 1,640 feet wide. And it didn't just create a hole in the ground. The impact was so intense that it produced a central peak, formed escalating ridges around the crater, and even left a damage zone that stretched out for thousands of miles. Using those super detailed images, the scientists have managed to reconstruct what happened right after the asteroid hit the surface of our planet. First, it slammed into the ocean, creating an initial bowl-shaped crater. As the shockwave spread, the seabed was shaken so violently that it triggered landslides, and the soft sediment surrounding the crater collapsed inward, creating a noticeable brim. As you already know, the impact also triggered a tsunami, and it was so shockingly powerful that its waves didn't just go outward, they actually turned back towards the crater, leaving huge scars on the ocean floor. And this wasn't just one big wave. No, it was a whole series of them, a train of tsunamis smashing everything in their path. Now, this second asteroid impact is a huge deal for scientists. It's a rare opportunity to study a marine impact crater in such incredible detail. There are only about 20 confirmed marine craters in the world, and none of them have been captured with this level of precision before. Plus, this data allows scientists to test new ideas about how craters form in water. You see, unlike craters on land, marine craters are hidden under layers of sediment, which makes them tricky to study. But with this new 3D imaging, we can look at the crater in all its layers. It's like slicing into a cake to see what's inside. Dr. Nicholson and his team are now dreaming of drilling into the crater and recovering samples from deep below the ocean floor. This would allow them to measure the shock pressure during the impact and figure out what happened in the minutes, hours, and days following the collision. Of course, the Chicxulub asteroid is still the star of the show when it comes to the dinosaurs' extinction. This space traveler was giant, somewhere between 6 and 9 miles wide. It hit Earth at a devastating angle, sending vaporized rock and gas into the atmosphere. It caused an impact winter that lasted for 15 years, because all that stuff blocked out the sun and plunged Earth into darkness. Now, probably the most intriguing thing is that some experts think the Nader asteroid might have been a chunk that had broken off from Chicxulub before it hit Earth. It's still just a theory, but if true, it could mean that Earth got hit by a double whammy from space. Now, let's travel back in time to the year 1908 in Siberia. Look around. You see nothing but trees and rivers. And suddenly, a huge object, around 150 to 300 feet in diameter, dashes through the Earth's atmosphere. Is it a comet? An asteroid? Scientists aren't sure. What they do know for sure is that this intruder blew up in the sky over Tunguska, leading to one of the most powerful blasts in recorded history. It completely leveled the forest below, knocking out 80 million trees over an area of around 830 square miles. And that's an area larger than that of cities like Los Angeles or New York. The trees were literally flattened, and their trunks were stripped of branches. They were also arranged in a bizarre radial pattern around the epicenter. But what if this explosion had happened over a city? Every single building would have been destroyed, and countless lives would have been lost. Luckily, this disaster occurred in a super remote part of Siberia. The creepiest thing, though? When scientists finally reached the area years later, they found no impact crater. No wonder it led to even more mystery. The most logical explanation is that when the object went off in the sky, probably around 3 to 6 miles above the ground, it blew up before it could hit the ground, and still, it didn't stop the blast from leveling an entire forest. Fast forward to 2013 and another mind-blowing event, this time over a much more populated area, the city of Chelyabinsk. It was a regular February morning when an asteroid about 60 feet in diameter entered Earth's atmosphere, lighting up the sky. It was moving at a staggering speed of around 43,000 miles per hour. It blew up in midair, about 18 miles above the city. It was a horrific view, but luckily, the asteroid disintegrated high enough in the atmosphere without hitting the ground. If it had touched down, the city would have been in big trouble, because even though there was no direct impact, the explosion still created a shockwave that tore through the atmosphere, hitting the ground with enough force to shatter windows all over the place. The blast damaged around 7,200 buildings, but fortunately, there were no direct fatalities. Still, it was a major wake-up call. This wasn't just some far-off cosmic event like Tunguska. This asteroid exploded over a modern populated area, and the damage was very real. The good news? Scientists are getting better at spotting such objects before they get too close. Space agencies around the world, like NASA, are tracking near-Earth objects to figure out which ones could pose a risk. But as we can see from these two events, sometimes space rocks can still sneak up on us. And while the chances of a major impact are low, the stakes are really high. At the moment, there's one asteroid that NASA's keeping an eye on. It's called Bennu, and it's about the same size as the Nader impactor. Bennu is considered one of the most hazardous objects in near-Earth orbit. According to NASA, there's a small chance it could hit the Earth between the years 2178 and 2290, and the biggest risk date is September 24, 2182. But don't freak out just yet. The odds of the impact are only 1 in 2,700, but still, it's a reminder that Earth is always in the cosmic firing line.
A long time ago, a huge meteorite smashed into the Earth with a horrible destructive power. It was several times bigger than the one that wiped out the dinosaurs 65 million years ago. Luckily, there were no lives it could have taken, or else it would have been a real catastrophe. Now, scientists think it did leave behind a huge footprint, the massive Antarctica impact crater that is bigger than the entire state of New York. The location also has a gravitational Wilkes Land anomaly going on. At first, scientists noticed something weird here when they measured Earth's gravity in that region, a strange gravity hole, or a negative gravity anomaly. Later, with better technology, they found something even weirder. There was a positive gravity anomaly inside that gravity hole, a spot with stronger gravity. This kind of structure, called a mascon, short for mass concentration, often shows up in places where giant space rocks or meteorites have slammed into the planet. When a meteor hits hard enough, it punches through the Earth's crust and shakes the mantle below. It can spring back up and leave behind a super dense plug of material, which causes stronger gravity right in the center of the crater. It's something like a frosty donut, with ice filling the gap and a dense center rising up from underneath. In 2018, scientists used advanced scanning techniques to study and map the Wilkes Land meteorite impact in more detail than ever before. They saw that it wasn't a perfect circle, but more of a U-shape, and the northern part looked like something had broken it apart. It possibly happened when Australia split away from Antarctica about 35 million years ago. Some scientists even think you can still see parts of the crater in southern Australia today. This clue also supports the idea that the giant crater under Antarctica formed before the continents broke apart. There have been different ideas about what created this strange formation. Some said it might be a volcano or an eroded valley, or even a sedimentary basin. That is a place where sediments build up over millions of years. But many scientists now believe the most likely explanation is a massive meteor impact. It was possibly one of the biggest to ever hit Earth. A 2015 study even estimated the age of the crater as its size matches the kind of space rocks that smashed into Earth between 4.1 and 3.8 billion years ago. The Wilkes Land meteorite impact was so powerful because the meteor that caused it could have been up to 30 miles wide. That's 4 to 5 times wider than the Chicxulub meteor that wiped out the dinosaurs 66 million years ago. Even that meteor was enough to cause massive destruction with wildfires, acid rain, tsunamis, and a climate crash that wiped out about 75% of all existing life. So it was lucky in a way that the meteorite that gave us the giant crater under Antarctica visited at a time when there were only microbes and no plants or animals on Earth. It didn't cause mass extinction or leave behind charcoal from ancient fires, but it may have changed the entire planet. Still, scientists haven't put the Wilkes Land anomaly mystery in the solved files because the crater is buried deep under Antarctica's thick ice sheet. It's hard to study up close. Scientists say we can't rule out the other ideas just yet, but if the meteor theory is right, then the Wilkes Land crater could be the largest known impact crater on Earth. So far, this title belongs to another contestant, the Vredefort crater in South Africa. Right now, the crater is around 99 miles wide, which is huge. But it's not as wide as the Chicxulub crater in Mexico, which is about 112 miles wide. But the Vredefort crater used to be way bigger, around 155 to 174 miles wide, before time and erosion wore it down. That means even though the Chicxulub impact was striking, the Vredefort impact was likely even more powerful, the biggest one we know of that hit Earth. According to the latest study, that asteroid was 12.4 to 15.5 miles wide and might have hit Earth at a speed of 45,000 to 56,000 miles per hour. It's important for science because knowing the real size of this impact helps us build better models to understand Earth's geology and how giant impacts shape planets, even beyond Earth. Measuring ancient craters is really tricky. Over 2 billion years, erosion wears away the edges and newer rocks form over the crater. That's what happened to Vredefort. Now, only small bits of the original crater rim are visible, and the rest is hidden under newer rock. To figure out its true size, scientists studied minerals like quartz and zircon found around the crater. These minerals still have fractures and shock patterns that show us how powerful the blast was. Wilkes Land anomaly isn't the only case on our planet where gravity is acting weirdly. For over 40 years, scientists were trying to solve a strange mystery in Canada. Parts of the country, especially around Hudson Bay, seem to have less gravity than the rest of the world. That means if you stepped on a scale there, you'd weigh just a tiny bit less than usual. Researchers first discovered this weird difference in the 1960s when they were mapping Earth's gravity. Gravity is linked to mass. The more mass there is, the stronger the gravity. And since Earth isn't shaped perfectly like a ball but is slightly squashed at the poles and bulges at the equator, it makes sense that its mass isn't spread out evenly. So, the first out of the two main theories to explain the Hudson Bay mystery has to do with magma. Yes, that super hot, gooey rock deep under our planet's surface. Magma constantly churns like boiling soup in a process called convection. As this magma moves, it can drag parts of Earth's crust down with it. That makes the area lighter, which lowers the gravity. The second area has to do with the Laurentide ice sheet, a massive glacier that covered much of Canada during the last ice age. This ice was up to 2.3 miles thick in some parts of Hudson's Bay. That's like stacking 10 Empire State Buildings on top of each other. Because it was so heavy, the ice pressed the land down like a thumb on a sponge. Even though the ice melted away about 10,000 years ago, the land underneath is still slowly bouncing back, kind of like a memory foam mattress after you get up. This slow rise is called glacial rebound, and it's happening at less than half an inch per year. Until the land fully bounces back, which could take 5,000 more years, it will continue to have less mass, and that means less gravity. Both of these theories are right. To figure this out, scientists used super advanced satellites, which floated around 300 miles above Earth for several years. These satellites flew in pairs and detected how far apart they were pulled as they passed over areas like Hudson Bay to measure tiny changes in gravity. When the front satellite passed over a low-gravity area, it drifted just slightly, and that change was recorded. Thanks to this research, scientists created detailed maps showing what Hudson Bay looked like during the last ice age. They discovered two huge bulges on the west and east sides, where the ice was thickest. And those spots have the weakest gravity today. The effects of this are still visible, and while sea levels are rising in most parts of the world, the land around Hudson Bay is rising so fast that sea levels there are actually dropping. Solving mysteries like this or the Antarctica impact crater anomaly gives scientists amazing insights into the past of our planet. And by understanding how past changes in temperature and geology affected Earth, scientists can predict how today's human activity can impact our future.
It seems the Arctic is literally exploding. Over time, huge craters began to appear, and what was once a near-perfect landscape is now filled with dark, ice-covered chasms. Now, you might think this is a treat for scientists, but the reality may be scarier than we imagine. The problem is that the phenomenon became a big mystery even for them, and no one found answers for a long time. The first crater was about 164 feet deep, and it was in 2014 that a helicopter pilot flying over the Arctic permafrost discovered it. But here's the wild part. While experts were still debating how it had appeared, other craters emerged in the same area, and they didn't stop. Over the next 10 years, these mysterious holes just kept popping up in the ground. Researchers raised a series of hypotheses, such as the idea that meteors hit the site, or even the possibility of extraterrestrial activity, to justify the sudden appearance of the holes. However, after digging a little deeper, they found elevated levels of methane gas in the air around the craters. Here's how it works. The Arctic's interior soil is rich in this gas, which builds up over time, gradually forming small mounds on the surface. When the pressure of the methane gets too much for the ground above, there's a huge explosion. The mound splits open, creating a massive hole and releasing all that trapped gas. Mystery solved. Or is this just the beginning? There were still a lot of unanswered questions. At first, they thought the explosions were just chemical reactions. Makes sense, right? But here's the catch. No one ever saw flashes of light or found any signs of burning in the craters. If there was no fire, then something else had to be at play. That meant there had to be a physical force, something powerful enough to blast those giant holes into the ground. But what could it be? It all comes down to the Arctic's unique geology. Picture Earth's layers, the core, mantle, and crust. The Arctic ground has a similar setup: regular soil on top, a thick frozen permafrost layer below, and then there's a solid layer of methane even deeper. And right between the permafrost and the methane, well, that's where the magic happens. There, tiny pockets of super salty, unfrozen water called cryopegs exist. But here's the crux of the matter. As ice in the soil melts, water seeps into these cryopegs, overfilling them. And since they can't handle the extra water, they start to expand. This puts pressure on everything above, creating fractures that creep up to the surface. Eventually, the pressure gets so intense that it cracks the solid methane layer, creating a sudden gas explosion. Hey, I can relate. It's a mixture of chemistry and physics unique to this region, and while it can take decades to happen, once it starts, there's no stopping it. One of the biggest concerns for scientists is figuring out where future explosions might occur. It's hard to estimate. Although this is a phenomenon specific to the region, we can't rule out the possibility of natural events with similar effects occurring in less isolated places, which would be an even bigger problem. But let's not get ahead of ourselves, and for now, let's just focus on the Arctic. The Arctic permafrost is full of surprises. And here's another one that sounds like something straight out of a sci-fi movie. Imagine a massive portal slowly opening in the ground, revealing ancient layers of Earth that haven't seen the light of day for over 650,000 years. Sounds unreal, but well, it does exist. Scientists call it the gateway to the underworld, a giant ever-growing crater in the Arctic known as the Batageka crater. Satellite images first revealed this creepy-looking sinkhole in 1991, but its history dates back even further. In the 1970s, part of a massive frozen slope collapsed, exposing a strange curved cliff above a deep depression. This bizarre shape immediately caught the attention of scientists. And here's where things get even crazier. After much analysis, they discovered that this isn't just any crater. It's the largest megaslump formation in the world. Its upper rim towers 180 feet high, about as tall as an 18-story building. But the real mind-blower? It's like a natural time machine. As the ice melts, it exposes frozen soil packed with fossils, ancient sediments, and even DNA from creatures that lived tens of thousands of years ago. So we get a glimpse of the animal and plant life that existed in the ancient world, right from the Arctic permafrost. In 2018, scientists made an insane discovery: a 42,000-year-old prehistoric foal, perfectly preserved, just like it had stepped out of a time machine, which gives us an idea of what is still buried there. But here's one thing: finds like this are super rare. Scientists aren't sure they'll ever come across another specimen in such perfect condition. Still, that doesn't mean the search is over. There are plenty of other hidden treasures just waiting to be discovered, clues that could help us unlock the secrets of early Earth. Now, when you think of the Arctic, what's the first thing that comes to mind? It is common to immediately think of ice, but here's a wild fact: it wasn't always frozen. Picture this: less than 1 million years ago, Greenland, the world's biggest frozen island, was actually covered in plants, flowers, and even tiny insects. Sounds crazy, but scientists have proof. And get this: the discovery came from an ice sample taken in 1993, which then sat forgotten in a lab for 30 years. When experts finally re-examined it, they weren't expecting much. But instead of just measuring isotopes, they found something unbelievable: fossils of ancient plants and insects buried deep inside the ice. Among them, moss, willow fragments, and even a perfectly preserved Arctic poppy. And here's why that's a game-changer: that flower only grows in soil, not on ice. So, at some point in history, the center of Greenland's ice sheet completely melted, making way for a full-blown ecosystem. This means that not only the edge of the region was once fertile soil, but the entire place. And here's where things get a little concerning. Ever heard the saying, "Looking to the past is looking into the future"? Well, if Greenland lost its ice before, that means it could happen again. And if it does, we're talking drastic changes, like rising sea levels that could flood entire cities, and even the release of ancient viruses and bacteria that have been frozen for thousands of years. So let's hope that this new melting doesn't happen quickly. And just when you think that Greenland's ice couldn't get any more mysterious, scientists have found a giant virus buried deep within it. It all started in 2019, when they were collecting samples of dark ice and reddish snow, trying to figure out why some parts of the ice weren't as white as they should have been. What they didn't expect was to stumble upon a giant virus hiding inside. Yep, this isn't your everyday little virus. We're talking about something much bigger than normal. This one is about 100 to 200 times larger than a typical virus and has a pretty weird behavior. Instead of attacking animals or humans, it goes after algae. Sounds bad, right? But we have a twist. It might actually help nature. By infecting algae, the virus darkens the ice, which makes it reflect less light, and that could slow down melting, acting like a natural sun shield for the Arctic. This was the first time giant viruses were ever found in Greenland's ice and snow. Scientists now want to find out what else it's hiding. Does it belong to a specific family? What else does it do for algae? Although there are clues, the hope is that these mysteries will be solved as soon as possible, and we will all know how it acts and how it can impact the Arctic. Well, one thing's for sure. Every new discovery like this teaches us more about our planet. And who knows? The next breakthrough could change the way we understand the frozen world, and maybe even our own future. Kaboom! One huge asteroid could be enough to wipe out all dinosaurs that ever roamed the Earth, leaving behind nothing but a huge crater. Yeah, we're in the Yucatan Peninsula, Mexico, and underneath there's Chicxulub, a massive crater. Now, if there's this immense hole, there must be a meteor too, right? Well, weirdly, no one has ever seen the actual remnants of the space rock itself. It's a bit weird, especially considering how important it is. After all, many think the same meteor that created the crater is the one that wiped out dinosaurs. Now, it might have vaporized on impact, creating a massive explosion. Most of the meteor could have turned into gas or tiny fragments scattered across the atmosphere. Or it might still be here, on Earth, just hiding. And scientists have finally discovered where to look for it. But it's not easy to reach. Around 66 million years ago, a giant asteroid went down and marked the end of the Cretaceous period. It slammed into what's now called Mexico, just north of Central America. The explosion from the impact triggered a global heat wave, which was followed by years of winter. It threw Earth into total chaos. The consequences of this catastrophe led to the extinction of more than 60% of life on Earth, including all the non-avian dinosaurs like T-Rex and Triceratops. It also took down flying reptiles, pterosaurs, and sea creatures like mosasaurs. Long story short, it was the end of the dinosaurs era. But don't be too sad about it, because it paved the way for the rise of mammals, and you and me. Anyway, scientists have recently figured out where the infamous asteroid came from and where it ended up. The thing wasn't just wandering around Earth's neighborhood. This massive rock might have formed beyond Jupiter and headed straight for our planet. But we'll talk about that a bit later. First, let's look more closely at the collision that created the Chicxulub crater. When the asteroid slammed into Earth, rocks from deep within the planet's crust were thrown up to 15.5 miles into the sky. It also created mountains taller than the Himalayas around the crater's edge. The asteroid itself, called the Chicxulub impactor, was about 6 to 9 miles in diameter. It hit Earth at a speed of around 12 miles per second, coming in at a 60-degree angle. I know we're not in a geometry class, but the angle is important here, since it was exactly right to send the maximum amount of vaporized rock into the atmosphere. As a result, massive plumes of sulfur gases and fine dust shot up, blocking out the sun and causing what's known as an impact winter, which lasted about 15 years. At the time, dinosaurs reigned on Earth. They'd been around for nearly 200 million years before the catastrophe led to their disappearance. The meteor theory seems all plausible, and all the facts add up, but even now, not everyone agrees with that. Some believe that dinosaurs were already on the brink of extinction before the asteroid impact, and the collision might have just sped up the process. Anyway, most dinosaurs were wiped out, but if scientists are right, then those who somehow managed to survive were the ancestors of modern-day birds. So we have an idea of what might have happened, but it took years of studies. The crater was first identified by scientists working for Pemex, a Mexican oil company, in the 1970s. And sometime later, scientists finally realized the mass extinction event that ended the Cretaceous period was because of the Chicxulub. One piece of evidence that pointed to the asteroid were the local fish back then. You see, when the asteroid struck, the immense force of the impact reshaped the planet's surface. For example, it turned rocks into glass-like spherules. Now, spherules are like small spherical particles that can form from the rapid cooling of molten silicate droplets. And some of these spherules ended up in the gills of fish that were wiped out by the impact. So, when during another research, scientists studied these fossils, it became obvious to them that the asteroid strike had happened during springtime in the northern hemisphere. They figured this out by studying the lines of growth in the fish's bones. Yep, those can be read just like tree rings. Of course, throughout many years, researchers continued exploring the impact site, hoping to find new data about the catastrophe. Their best bet was to turn to the chemical record left behind by the asteroid, the debris of which is hiding under all those layers of rock and sediment under the Yucatan Peninsula. So they studied the chemical signatures in rocks from the end of the Cretaceous period and found that the asteroid came from beyond Jupiter. And it wasn't just any asteroid. No, it was a carbonaceous chondrite, one of the oldest types of asteroids in the solar system. It most likely formed billions of years ago. These types of asteroids only come from the region beyond Jupiter. So the asteroid that caused the extinction event must have originated there. One of the main clues was ruthenium. It's a rare element in Earth's rocks, but much more common in asteroids. Scientists detected tiny amounts of ruthenium in the rocks, which helped them confirm that the asteroid came from outer space, not from a comet or volcanic eruptions. In 2016, scientists also published the first results from a drilling expedition into the Chicxulub crater. The team managed to drill more than 4,000 feet beneath the seafloor, getting their hands on core samples containing pieces of the original granite bedrock that was struck by the asteroid. These rocks are deeply shocked and placed out of order on top of sedimentary layers. It supports the theory that the peak ring of the Chicxulub crater formed through a dynamic collapse process. Now, about that peak ring. Scientists specifically targeted it in their exploration. The so-called ring is a circular ridge inside the crater rim. Similar peak rings can be found in the largest impact craters in our solar system, on the Moon, Mars, and Mercury. But on Earth, Chicxulub is the only well-preserved crater with a peak ring. This discovery also aligns with recent findings from NASA's lunar mission. It showed that the peak rings within the Orientale impact basin on the Moon had formed in an equivalent way to those at Chicxulub. The team is so eager to study the peak ring because they want to test their models of crater formation. Plus, they hope to find out whether this area could have been one of the first habitats for microbial life after the asteroid impact that wiped out dinosaurs. The peak ring formed just minutes after the impact. The deep granite bedrock, initially flowing like a liquid, rebounded into a central tower as tall as 6 miles before collapsing into the ridge we see today. This was followed by a layer of breccia. That's a jumble of rocks and impact melt. And after that, ocean tsunamis brought massive amounts of sandy sediment into the crater. Another find from 2016 was a 10-foot-long core, which revealed bits of granite and minerals from hot, fluid-filled cracks. That was a sign that they had finally entered the peak ring. Geophysicists from the University of Texas explained that they had expected the peak ring to be a large hydrothermal system, and they were drilling to confirm this. The team eventually reached deeper layers, drilling down to 4,380 feet. The team was able to collect most of the core samples they hoped to get, and the samples they got were in great shape. They also gathered lots of useful data from the early Paleocene period and completed a successful scan of the drill hole. Now, scientists from around the world will need some time to fully study and understand what these findings mean. but they're sure that this mission will help answer some big questions. Like what exactly happened when the asteroid hit, how it wiped out the dinosaurs, and how impacts like that affect life deep underground. While some astronomical events are pretty common, there are those which occur only once a year or once in 100 years. Let's have a look at the coolest and rarest events we might be able to see with our own eyes. The first amazing celestial event on our list is the Perseid meteor shower that will take place from the 17th of July to the 24th of August 2024. This event is going to be one of the most vibrant of the year. At its peak, between the 12th and 13th of August, you might see up to 100 meteors per hour, if you're in a dark place, that is. This meteor shower is caused by debris from the comet Swift-Tuttle. As meteors streak through Earth's atmosphere, they often leave behind long wakes of light and color. The perfect time for watching this cosmic show is right before dawn. On the 2nd of October 2024, we'll be able to watch a ring of fire solar eclipse. Its scientific name is an annular eclipse, and it occurs when the moon is slightly farther away from our planet. In this case, when the disks of the moon and the sun align, the moon's shadow doesn't completely block the sun's light. As a result, you can see a ring of sunlight around the moon. This time, the ring of fire will be visible in southern Chile and southern Argentina, so book your flights early. Another cool event that will occur this October is the Draconid meteor shower. During this event, meteors are more likely to fly in the evening hours than in the early morning. This is usually a slow shower, producing just a handful of meteors per hour. On the other hand, astronomers speak of a rare fiery Draco, which has been known to send many hundreds of meteors across the sky within a single hour. Are we going to get lucky this year? Time will show. Starting from the 12th of October and for the following week, you'll have a chance to see a comet passing by our planet. Now, even though this nearly unpronounceably named big boy will be about 40 million miles away from the Earth at its closest point, you might be able to see it with the unaided eye. Now, comets have a reputation of being quite unpredictable. Most of these dusty, icy space bodies are thought to have originated on the outskirts of the solar system millions of years ago, and there they spent most of their time in the dark, inert and unnoticed, like me in middle school. Now, some of them come closer to the sun, and many experts already forecast a fantastic celestial spectacle in October. So if you miss the meteor showers we've talked about, you'll be able to catch up. Orionid meteor showers will keep going from the 26th of September till the 22nd of November 2024. Sometimes this event can produce from 40 to 70 meteors per hour, but recently the maximum number was lower, from 20 to 30 visible meteors. And the final event for this year is going to be the Geminid meteor shower. And let me tell you, this event is going to be breathtaking. Astronomers claim that this meteor shower is one of the best of the year because of bright visible meteors. Around 120 shooting stars are likely to streak across the sky per hour. Interestingly, while most meteor showers come from comets consisting of dust and ice, the Geminids originate from a rocky asteroid. Scientists still don't know how to classify this asteroid since it has a tail and brightens as it comes closer to the sun, just like a comet. On the other hand, recently, astronomers have discovered that the asteroid's tail is not made up of dust, but of sodium gas. Alright, let's travel farther into the future. In 2029, we'll witness the darkest lunar eclipse of the century. A lunar eclipse occurs when our natural satellite completely hides in Earth's shadow. Sometimes, when it happens, the moon can look bright red. Normally, the closer the moon is to the center of the shadow of our planet, the darker the eclipse is. And, according to experts, the eclipse on June 26, 2029 will be extremely dark. It will last for about an hour and 42 minutes and will be the most visible in South America. So, again, don't forget to book your tickets. A supermoon that's also the second full moon to occur within 1 month is known as a blue supermoon. Such supermoons don't follow a regular schedule and occur every 10 years or so. According to NASA, the next blue supermoons will happen in January and March 2037. Then, 3 years later, in 2040, we'll witness the parade of planets, when 5 planets of the solar system, Mercury, Venus, Mars, Jupiter, and Saturn, will line up. Of course, it won't be a perfectly straight line, but it will still be a pretty impressive view. Some planets, like Venus and Jupiter, can be clearly observed even in big cities and with the unaided eye. But during the parade of planets, you'll be able to see more, so perhaps it's time to stock up on telescopes. The brightest supermoon of the 21st century will occur in 2052. The thing is, the orbit of our natural satellite isn't perfectly round. The moon follows an elliptical path while traveling around Earth. That's why there are 2 points closest to Earth, called the perigee, and the farthest, known as the apogee. On the 6th of December 2052, we'll see a stunning supermoon. Our satellite will be around 221,000 miles away from our planet, which is closer than normally. In 2060, we're likely to see a comet called 15P Finlay. It will be one of the closest comets to approach our planet in the last 100 years. It'll fly by at a distance of around 3.1 million miles. And here's the thing. Every time a comet comes close to the Sun, it heats up and starts emitting gases and dust, looking like a little star. Thanks to solar winds, it also gets a beautiful long tail. And the closer to Earth a comet passes, the brighter it looks in the sky. So get ready for a breathtaking show. In 2084, something known as an Earth eclipse will occur, becoming one of the most exciting events of the 21st century. Sadly, we won't be able to see this celestial spectacle from Earth, obviously, but we might be able to admire it from Mars. During this event, the Moon and Earth will pass by the Sun, looking like dark silhouettes. Such an event is known as a planetary transit, something like a solar eclipse, but with other planets instead of the Moon. Now, in 2100, for those of us still here, the North Star will be the closest to the North celestial pole. Sailors have been using this famous star for centuries to figure out where north is. But the funniest thing about this is that this star isn't perfectly aligned with north. The reason is that Earth doesn't have a fixed axis. It rotates in space like a giant spinning top in a process called orbital precession. That's why the North Star doesn't remain in the same place in the sky. It moves slowly but steadily. But on the 24th of March, 2100, the polar star will finally appear over the true north of our planet. And after that, it'll start moving away again, to return 26,000 years later. So as you can see, it's going to be a truly rare event. Plus, it'll be like a parting gift from the North Star. Since Earth's axis is constantly moving, in around 2,000 years, the North Star will be replaced by another, Gamma Cephalus. So, the close approach in 2100 will be the nearest it will be to our planet for a long time. So, I hope you've made notes of the most interesting astronomical events of the next 100 years. The coolest thing is that to witness most of them, you don't even need to buy a telescope. They're going to be visible to the unaided eye. Ooh, look at that! It was early morning on the 30th of June, 1908, when a terrifying explosion occurred in the sky above the stony Tunguska River in Siberia. It left 80 million trees flattened, and the affected territory was more than 820 square miles. Thousands of people within 900 miles experienced the Tunguska event, and later, researchers managed to collect more than 700 accounts. Most reports mentioned a fireball in the sky. It was glowing like a second sun. People also spoke about a series of explosions that produced frightful sounds. Sometime later, the ground started shaking as, according to some witnesses, the earth opened wide and everything started falling into the abyss. Was that what really happened? Scientists aren't 100% sure. The indigenous Yakuts in Evenks, for example, believe that a deity sent the fireball to get rid of our world for good. At the same time, numerous meteorological stations in Europe recorded both atmospheric and seismic waves. Days later, weird phenomena were observed in the sky over vast territories, reaching Europe. Those were glowing clouds, colorful sunsets, and even a weak luminescence at night. Some reports mention a blue tube in the sky. International newspapers were speculating about a powerful volcanic eruption. Some scientists thought it could have been a cosmic impact. Unfortunately, it was hard to access the region where the event had occurred, which prevented further scientific investigation. In 1921, mineralogist Leonid Kulik got interested in this story after reading a newspaper article that claimed that passengers of the Trans-Siberian Railway had seen the impact. There were even claims that some of them had managed to touch the still-hot meteorite. Kulik organized an expedition and traveled to the city of Kansk. There, he studied the reports about the event, everything he could find in the local archives. It turned out that the story about the train passengers seeing and encountering the meteorite was a hoax. But Kulik and his team didn't give up. They traveled to the region, following first the Angara River and then the Tunguska River. Then, on April 13, 1927, the researchers discovered a huge area littered with rotting logs. Some extremely powerful force must have flattened them. Shockingly, only at the epicenter of the blast, in the forest of Tunguska, some charred trees were still standing. But the most baffling thing was that even after exploring the entire area, the team didn't find an impact crater or any meteor material. So, in the fall of 1927, Kulik's report was published in different national and international papers. The scientists suggested that an iron meteorite could have exploded in the atmosphere, causing the observed powerful explosion and following devastation. He explained the lack of an identifiable impact site by the swampy ground. The soil could have been too soft for the impact crater to remain. So, despite the lack of physical evidence, Kulik called the event Filimonovo meteorite. Filimonovo was the railway station where people saw an ultra-bright light in the sky. Only sometime later did the incident get its name, Tunguska event. Even though this event is quite popular all over the world, scientific data describing it is sparse. Since 1928, more than 40 expeditions have explored the site. They took samples from the soil, rocks, trees, but the results were always ambiguous. Some seismic and air pressure wave registrations, which were recorded right after the blast, are still intact. Plus, about 30 years after the event, researchers mapped the area of the destroyed forest. But since there's almost no hard data, like a crater or a meteorite, and the accounts of the incident are conflicting, many theories of widely varying plausibility have appeared over the years. Among them, there was an asteroid skimming the atmosphere of our planet, and a primordial black hole passing directly through it. Wait, what? At the current age of the universe, black holes form when huge stars run out of fuel and collapse under their own gravity. In other words, there's a limit to how small a black hole can be in the current universe. It has to form from substantial amounts of mass gathered in one small region of space. Plus, it can only occur to stars around 20 times the mass of our Sun and larger. But primordial black holes are something else altogether. Their existence hasn't been proven yet, so they remain purely hypothetical. Primordial black holes could have formed in the first few seconds of the existence of the universe. At that stage of its development, all the stuff that would later continue to create stars and galaxies were packed together much more tightly. At that time, pockets of hot material might have been dense enough to form various black holes, from giant to teeny-tiny ones. The masses of such holes could have been 100,000 times smaller than that of a paperclip. At the same time, these holes could have reached a mass of 100,000 solar masses. Soon after, the universe started to expand very quickly, and it also cooled down. This put an end to the conditions favorable for the formation of primordial black holes. Unfortunately, we haven't detected any such holes yet. But if they formed right after the birth of the universe, it's possible that they might still be somewhere out there. And there's an idea that primordial black holes, smaller than an atom, might be passing through Earth every day without harming our home planet. A larger primordial hole might also visit us every once in a while, every 1,000 years or so. After learning more about the Tunguska event, a team of physicists published an article in a 1973 Nature paper that the event itself could have been caused by a primordial black hole passing through the planet. The researchers stated that a black hole with the mass of a large asteroid could explain the lack of a crater or any other physical evidence of the impact. Blue light noticed by witnesses seemed to fit this theory too. According to the team, in such a case, most of the radiation from the shock front would be in the ultraviolet vacuum. It would then get absorbed and re-radiated at longer wavelengths. There would be just a bit of hard X radiation, and the accompanying plasma column would look deep blue. Admittedly, it's a very unusual theory, but the team also suggested a way their idea could be tested by looking for signs of an exit wound on the other side of the planet. You see, if a black hole entered Earth, the rigidity of the rock wouldn't allow for any underground shockwave. Because of the black hole's high velocity, and because it would only lose a tiny fraction of its energy while passing through our planet, it would follow almost a straight line through the planet. Such a potential exit could provide a check for the entire hypothesis. The team also suggested looking for shock waves and disturbances in the ocean on the opposite side of the world. But there's a problem with the idea of a black hole passing through Earth. Such a black hole could settle into the core of our planet, and its gravity would allow the black hole to start feeding, eventually devouring our entire world. Plus, there would be a lot of heating. You see, during its passage through Earth, the black hole would gather a lot of matter, and this process would produce a lot of heat. To put it simply, the impact of an asteroid-mass black hole would release almost the same amount of energy as the impact of an asteroid, like the one that destroyed dinosaurs. Luckily, according to the existing calculations, the chances of a black hole settling in the core of our planet are minimal, since black holes are just too fast to do so. In any case, the Tunguska event being a black hole passing through our planet is certainly an exciting idea, but no evidence that could prove it has been found yet. Plus, we still don't know whether primordial black holes exist at all. Yep, it's something to ponder.
Imagine sitting at home, drinking coffee, and watching a new episode of your favorite series. And suddenly, boom, crash! What's happened? Nothing terrible, just a meteorite that has just crashed into your kitchen after breaking the roof. You might think this story is entirely made up. But that's what actually happened in New Jersey during the Eta Aquarid meteor shower, which is active from April 19th to May 28th and peaking on May 5th through 6th. The space rock itself was the size of a pork roll sandwich. It was also pitch black and weighed almost 4 pounds. It slammed through the roof and hit the wooden floor, ruining it. When the inhabitants of the house found the rock and touched it, it was still warm. Luckily, the thing wasn't radioactive and there was no one at home at the time this intruder arrived. But the most shocking thing about this meteorite? Astronomers believe it might have come from a cosmic snowball traveling far, far away from Earth. To explain this, I'll have to tell you a bit more about the Eta Aquarid. This meteor shower is famous for its fast meteors, leaving long, glowing trails. It's produced by Comet Halley, completing its orbit around the Sun every 76 years. The comet hasn't visited Earth since 1986 and won't come back until 2061. Right now, it's somewhere near the constellation of Hydra, which is more than 100 light-years away from our planet. Every year, Earth has to pass through trails of debris left by the comet. They collide with our atmosphere, disintegrate, and create beautiful, colorful streaks in the night sky. And it happens every time Halley returns to the inner solar system. Its nucleus sheds a layer of ice and rock into space, and some of it reaches our planet. The Central New Jersey authorities believe the meteorite that sneaked into the house originated from that meteor shower. But I feel that you might be pondering another question that confuses many people. What's the difference between all those space bodies? I mean, there are so many of them flying out there. Meteors, meteorites, asteroids, comets. Ugh. Okay, let's figure it out together. An asteroid is a rocky body orbiting the sun. It's usually not very big and quite inactive. Comets are different. They're covered with ice that normally evaporates in sunlight, forming a coma, which is what a comet's atmosphere is called. This coma consists of dust and gas. A comet also has a tail that is made of dust and/or gas too. A meteoroid is a small part of a comet or asteroid that orbits the sun. If this meteoroid manages to sneak into Earth's atmosphere and vaporize there, it's a meteor. It's often called a shooting star. And finally, if a meteoroid manages to survive the passage through our planet's atmosphere and lands on Earth's surface, it becomes a meteorite. If you think such space guests are a rare occurrence, that's not exactly true. Every day our planet is hit with more than 100 tons of sand-sized particles. About once a year, a large, car-sized asteroid enters Earth's atmosphere, turns into an impressive fireball and burns, luckily, before reaching the surface of the planet. And every 2,000 years or so, a meteoroid the size of a soccer field hits Earth, causing a lot of damage. And now, imagine this. A huge, really ginormous asteroid is approaching our planet. There's no one on Earth to predict its appearance. Neither is there anyone to stop it. That's why soon, the asteroid crashes into the surface of Earth. The force of the collision is so powerful that the space visitor doesn't stop until it gets through the crust to a depth of several miles. The impact leaves a crater of more than 100 miles across. Thousands of cubic miles of solid rock instantly turn into vapor. The crash sets off a series of natural disasters that erase 75% of life on Earth. The creatures that were close enough to see the crash don't survive for longer than a few seconds. Even closer to the impact crater, the ground is covered with thousands of feet of hot ash, grit, and rubble. Several seconds later, everything for many miles around bursts into flames. What doesn't burn down within the next several minutes after the collision faces a different, even more terrifying fate. The asteroid causes a monstrous, largest ever tsunami. A recent study claims that it was thousands of times more powerful than any wave people have ever seen. The tsunami was so devastating, it eroded seafloor sediments half a world away. The team of scientists even remodeled the events of the first 10 minutes after the impact, and the model showed that the asteroid had produced waves up to 30,000 times greater than one of the largest tsunamis people have ever recorded, the one in the Indian Ocean in 2004. You've probably already guessed that I'm talking about a real-life event, namely the asteroid collision that wiped dinosaurs off the face of the Earth. The Chicxulub asteroid, as we now know it, is believed to come from the outer reaches of the solar system. This space body was at least 6 miles across. It crashed into the shallow seawaters near the Yucatan Peninsula. The impact was so powerful that it left its signature on the face of the planet. In 2021, researchers found out that the collision had carved mega ripples into Earth's crust in the region of modern-day central Louisiana. But such devastating events, when an object that large threatens Earth's inhabitants, happen very rarely, once every few million years. Space rocks smaller than 80 feet usually burn up in the atmosphere of our planet, causing little to no damage. If a rocky meteoroid larger than 80 feet but smaller than half a mile across was to hit Earth, it would cause local damage to the impact area. As for a space rock with a diameter larger than half a mile, it'd likely have worldwide effects. And these space bodies aren't even the largest. For comparison, asteroids populating the main asteroid belt between Mars and Jupiter can be as huge as 580 miles across. But you can breathe out. They're too far away, and don't pose any threat to our planet. All the time, our scientists keep learning more and more about hazardous asteroids and comets. They have even established a Planetary Defense Coordination Office, aka PDCO. It ensures that potentially hazardous objects get detected as early as possible. An object is considered potentially hazardous if its orbit is predicted to bring it within 5 million miles of Earth. It should also be large enough to reach the surface of our planet, over 100 feet across. Interestingly, a meteorite impact isn't the worst thing you need to worry about. Some scientists warn that the most dangerous thing is the shock wave produced by a meteor breaking apart in the atmosphere. For example, one meteor, which originally was an asteroid the size of a 6-story building, entered our planet's atmosphere in February 2013 and broke apart 15 miles above the ground. This generated a shockwave that was equivalent to a ginormous explosion. An even larger space visitor was called the Tunguska meteorite. It was also 10 times more energetic. It broke into pieces over the Tunguska River in June 1908, flattening 500,000 acres of forest. If the meteorite hadn't been so huge, this event would have gone undetected because of the remote location where it all happened. So it's a good thing that 90 to 95% of meteors don't survive the fall through our planet's atmosphere. Only those that are made of stronger materials make it so far. Most meteorites, though, are thought to come from comets, which are way more fragile than asteroids. We should also consider the speed of a meteor. If one is approaching Earth at a slower speed, it's more likely to survive the collision with the atmosphere of our planet. It means that the meteor won't burn completely, and some of its remains will reach the ground.
In February 2025, scientists detected an asteroid heading our way. If it hit, it would create a crater the size of Manhattan and unleash a shockwave strong enough to flatten everything within 30 miles. Uh-oh, I'm out of here. Well, luckily for now, we're in the clear. But the threat is coming back in 2028, and this time, everything might change. You see, in 2025, NASA announced that an asteroid called 2024 YR4 had a 3.1% chance of hitting Earth in 2032. Now, in asteroid terms, that's high enough to sound the alarm. The asteroid itself is not the end of the dinosaurs level, but it's big enough to level a city. The rock is about 130 to 300 feet wide. That's roughly the size of a large jet. Now, if something that size slammed into a populated area, it wouldn't end the world, but it would result in a very, very bad day. And still, no one panicked, and scientists weren't scrambling for bunkers. Because when we first spot an asteroid, we have to work with limited information. It's like seeing a plane high up in the sky and trying to guess exactly which gate it'll park at. That's why astronomers rush to gather more data. The asteroid itself seemed pretty ordinary. It was rocky, not some rare metal thing. It was first spotted in late 2024 by an observatory in Chile during a regular skyscan routine. There's this group called the International Asteroid Warning Network. Their job is to keep an eye on space rocks that might try to ruin your day. And back on January 29, 2025, they announced that the chances of that particular asteroid hitting Earth had gone over 1%. Now, 1% might not sound like much, but that's enough to make scientists start worrying. The impact risk for 2024 YR4 reached its highest point on February 18, 2025. That's when scientists calculated a 3.1% chance it could hit Earth. But by February 23, after more observations came in, that possibility was essentially ruled out completely. The asteroid's Torino scale rating, which is used to categorize the impact risk of near-Earth objects like asteroids and comets within the next 100 years, was lowered to 0. It means it's no longer considered a threat to Earth. Well, for now. But scientists still keep tracking it, and based on additional data, there is now a 4% chance it could hit the Moon instead. If that were to happen, it would be on December 22, 2032. Right now, the asteroid is expected to pass about 5,600 miles from the Moon's surface. However, there is a very large uncertainty range, about plus or minus 46,000 miles, so it could easily miss the Moon by a very large distance. The last time we had something this dangerous was back in 2004, with an asteroid called 99942 Apophis. Back then, it had a 2.7 chance of hitting Earth in 2029. People were sweating. But after better observations, scientists ruled out the impact. This time we actually passed that old record. 2024 YR4 is currently heading out toward Jupiter's neighborhood and won't swing back close to us until 2028. And that's when everything might change. If the risk jumps above 10%, the IAWN will send out a formal warning to the United Nations. They'll tell countries in possible impact zones to maybe start preparing, because if we talk about the damage… Admittedly, this asteroid is not the 6-mile-wide monster that wiped out the dinosaurs 66 million years ago after hitting Earth. This here asteroid is in the city killer category. It sounds dramatic because it is, but it's not some global extinction stuff. The real problem isn't just its size, it's its speed. If the asteroid hits, it could be moving nearly 40,000 miles per hour. That's like flying from New York to LA in under 5 minutes. But still, the most likely scenario would be the asteroid exploding in the air before even hitting the ground. That's called an airburst. But if the asteroid is on the bigger end of the size estimates, it could actually reach the surface of our planet, slam into the ground, and make a crater. So that possibility's still on the table. As for where it could hit, the possible impact zone covers a huge area: Eastern Pacific, Northern South America, the Atlantic, Africa, the Arabian Peninsula, and South Asia. Raise your hand if we left you out. Keep in mind, though, that it's way too early to make life decisions based on that. So, no packing up and moving yet. Besides, we're not sitting here helpless. In 2022, NASA pulled off the DART mission, where they literally smashed a spacecraft into an asteroid to nudge it off course. And it worked. DART stands for Double Asteroid Redirection Test. It was built for NASA's Planetary Defense Office. They wanted to know if we could push an asteroid just enough for it to miss our planet. So they launched a spacecraft in November 2022, and it traveled through space for about 10 months. The plan from day one was to crash it. The target was a small asteroid moon called Dimorphos, which is about 530 feet across, the size of a large stadium. Dimorphos orbits a bigger asteroid called Didymos. The two of them just circle each other out there in space. What's important is that neither of them was threatening Earth, so this was a safe test. Now, DART was basically a heavy spacecraft with a camera and a smart guidance system. The strategy was to hit Dimorphos at about 14,000 miles per hour and let the force of that impact slightly change its orbit. In the final stretch, the spacecraft guided itself. It had to figure out which rock was which, lock onto the smaller one, and adjust its path without anyone steering it in real time. When it hit, the onboard camera sent back close-up images right up until the moment of impact. Then the signal stopped because the spacecraft had done its job and smashed into the asteroid. There was also a small Italian CubeSat that separated earlier and stayed back to photograph the collision and the resulting debris cloud. Those images showed a huge plume of rock and dust blasting out into space. Well, after that, astronomers around the world started measuring the orbit of Dimorphos very carefully. Before the collision, it took 11 hours and 55 minutes to circle Didymos. After the impact, it took 11 hours and 23 minutes. That's an impressive 32-minute difference. The interesting part was that the spacecraft alone wasn't responsible for all of that shift. When DART struck the surface, it threw tons of rocky material outward. All that rock and dust blasting off gave the asteroid an extra push, stronger than the spacecraft alone could have done. Scientists later realized that Dimorphos wasn't a solid chunk of rock. It was more like a loose pile of rubble held together by gravity. That probably helped produce more debris and a bigger push. So if we ever face a denser, more solid asteroid, the same technique might not have the same exact effect. That's why scientists are also looking at other ideas, like using lasers to heat up part of the asteroid so bits of rock fly off and slowly push it in the opposite direction, like giving it a tiny built-in rocket. Or they could place a spacecraft close to the asteroid and use its gravity to slowly pull it off course, like a small tugboat guiding a huge ship. Or if things got really serious, use a nuclear blast as a last resort shove. Despite the success of the DART mission, NASA says we do not have a ready, reliable system that could stop a city-killing asteroid if one suddenly shows up on a collision course with Earth. The danger isn't the giant dinosaur-level asteroids. Those are huge and easy to track. Neither is it tiny rocks that burn up in the atmosphere all the time. It's the middle-sized ones, around 500 feet wide. Scientists estimate there are about 25,000 near-Earth objects in that size range moving near Earth's orbit. So far, we've only found about 40% of them. That means most of them are still out there, and we don't know exactly where they are. The problem is they're dark. Most don't reflect much sunlight, so even powerful telescopes can miss them. To help fix that, NASA plans to launch a new space telescope called the Near-Earth Object Surveyor. Instead of looking for sunlight bouncing off asteroids, it'll look for heat. Even a dark asteroid absorbs sunlight and gives off heat, and that's easier to see in infrared. A huge asteroid, several hundred feet across, is dashing towards Earth through the black nothingness of the cosmos. Ooh. Brace for the terrible news. There's a 72% chance it might hit Earth in 14 years, with potential impact zones being North America, Southern Europe, and North Africa, some of the most densely populated areas on the planet. Astronomers have been keeping a close eye on the space invader for a few months, but now it's moved too close to the Sun, and tracking it is impossible for the next 7 months. Of course, there's a 28% chance that it will miss our planet altogether. But what if it doesn't? Global devastation and destruction, that's what. Thousands of lives lost, billions and billions of dollars in damage, entire species wiped off the face of the earth, ruined cities and towns, destroyed fields and forests. We're left wondering whether it's the future awaiting for us. Well, now you can breathe easy. That's just a hypothetical scenario created by NASA to prepare for a situation like this. The space agency has been thinking about this kind of disaster for years. Even cooler, they run what-if asteroid exercises every 2 years to get scientists, state agencies, and international experts on the same page. The last one occurred in April. Over 100 people took part in that event. During such asteroid drills, experts pretend that a giant space rock is heading our way. Then they work through all the tricky questions they can come up with, like how big is it? Where might it hit? What should we do? It's like a massive brainstorming session to make sure that if it ever happens, we won't have to start from scratch. To make these scenarios feel as real as possible, NASA's Center for Near-Earth Object Studies gets involved. These are folks who track real asteroids and calculate their orbits. So they simulate months of asteroid observations, complete with uncertainties about its size, trajectory, and potential impact zones. It's the kind of uncertainty that makes decision-making way harder, just like it would be in real life. Now, if an astronaut really was aiming at Earth, it wouldn't be just one country's problem. It would be everyone's. That's why this exercise brings in international experts. In April, it happened for the first time. They worked alongside U.S. agencies like NASA's Planetary Defense Coordination Office and FEMA to understand how the world might respond to such a crisis, since an asteroid impact would have dire consequences globally. Now, the big question is, can we actually stop an asteroid from hitting Earth? Here, there are two main options experts consider. First, we could send a spacecraft to gather more info. If we knew more about the asteroid's size, mass, and orbit, we'd be able to make better decisions about what to do next. The second option is to try to deflect it. Basically, it means bumping the asteroid off its course so that it misses Earth. This might sound impossible, but NASA's DART mission has already proven that we can do it. 2 years ago, they crashed a spacecraft into a small asteroid called Dimorphos and successfully changed its orbit. It was a huge victory for planetary defense. But missions like that take tons of time to plan, prepare, and carry out. That's why spotting dangerous asteroids as early as possible is so important. Currently, NASA is working on a new telescope called NEO Surveyor, which is set to launch in 2027. Unlike good old telescopes, NEO Surveyor is designed to detect even the trickiest asteroids, including ones orbiting close to the Sun. It'll give us a better chance to act early and potentially stop an asteroid before it becomes a threat. If you still think that an asteroid impact is something out of science fiction and the threat isn't real, how about this? Early on Sunday, January 21st, a small asteroid about 3 feet wide entered Earth's atmosphere and luckily burned up over Germany. NASA's Scout Impact System spotted it 95 minutes before it hit and predicted exactly when and where it would arrive. At 1:32 a.m. local time, the asteroid turned into a blazing bright fireball, visible as far away as the Czech Republic. Some small meteorites might have landed near the impact site, about 37 miles west of Berlin. This is just the 8th time ever that an asteroid has been detected before it hit Earth. It's a splendid example of how tools like Scout are helping us track asteroids and prepare for anything bigger that might come our way. Here's another example. A small asteroid turned the skies over northeastern Siberia into a breathtaking light show on December the 4th, burning up harmlessly in Earth's atmosphere. The space rock, about 28 inches across, was spotted just hours before it hit. Thanks to observations from astronomers around the world, a special alert system managed to predict the impact to plus or minus 10 seconds. The asteroid entered Earth's atmosphere at 1:15 a.m. local time. The authorities were put on alert, but there was no damage reports. NASA's Asteroid Terrestrial Impact Last Alert System, or ATLAS, spotted the rock 12 hours before it entered the atmosphere. This makes it the 4th imminent impactor, which is an asteroid discovered within hours of its expected impact, detected this year, and the 11th overall. Now, China also has big plans for planetary defense. They're working on their first mission to hit an asteroid, and it's got a double purpose. One spacecraft will crash into the asteroid, and the other will hang back to study the whole thing for up to a year. In other words, it's not just about protecting Earth, it's also a way to learn more about the solar system. The target is an asteroid called 2015 XF261, which is a mouthful, and also about 100 feet wide. It flew by Earth recently on July 9, passing us at 31 million miles. True, it's pretty far away, but the space traveler was zooming by at a speed of 26,000 miles per hour, 30 times faster than the speed of sound. China is going to send a space probe to study the asteroid. They're hoping to learn more about its structure and composition, which could help us with future planetary defense missions. Then they plan to hit the asteroid with another spacecraft to test the impact, and the first space probe will stay there to observe the remains for up to a year. Timing is critical for this mission, and the asteroid offers some good opportunities in the next few years. Thus, in March and May of 2027, the asteroid will pass within 20 million miles of Earth. In April 2028, it'll get even closer. By that I mean 13 million miles away. A year later, in April 2029, the asteroid will end up just 4.2 million miles away, making it the best shot for a mission. Another decent chance will be April 2030. That's when the asteroid will pass our planet at 4.4 million miles. To give you some context, NASA's DART mission once targeted an asteroid 7 million miles away, and the trip took 10 months. So China's planners have to pick the right moment, depending on how long their spacecraft will need to get there. The mission is expected to start around 2027. At the same time, this won't be China's first attempt to target an asteroid. Back in 2023, they were planning a planetary defense test with a different asteroid, which is also about 100 feet wide. It's not clear why they switched to the current one, probably because the timing works better. Most asteroids are basically time capsules from 4.6 billion years ago, leftovers from when the solar system was just forming. Studying them could tell us a lot about how planets, including Earth, came to be. So, China's taking on something that combines planetary defense and pure space science. They're definitely making big moves in the space exploration game. If an asteroid like Apophis hits Earth, we will be destroyed. Massive earthquakes will strike, and tsunamis will flood everything. Apophis is a billion-year-old celestial body that has been in the solar system since its inception. So you might be thinking, well, how likely is it that this giant space stone will collide with our planet in 2029? Well, let's find out, shall we? Apophis is a big, bad asteroid discovered in 2004 by the Kitt Peak National Observatory in Arizona. Since then, it has proudly held the title of one of the most dangerous asteroids ever located. It's around 1,100 feet wide, which is a bit bigger than the Empire State Building and the Eiffel Tower. Because of how scary it is, it was named Apophis, like the Egyptian immortal creature that was considered to bring eternal darkness and destruction to Earth. Oh boy. In 2021, researchers had a once-in-a-lifetime opportunity to study this floating rock when it passed near our planet, and we'll come back to that in a minute. Now, some scientists say that there is a small chance of Apophis hitting the Earth on Friday, April 13, 2029. The Yarkovsky effect is to blame for this, since it can slightly nudge this space rock towards Earth. This effect originates from the uneven emission of thermal photons from a rotating celestial object, resulting in a fascinating force exerted upon it in space. These emitted photons possess momentum and play a pivotal role in shaping the dynamics of the body. The asteroid has two sides, light and dark, just like the Moon. The light side faces the Sun and is warmer than the dark side. But the thing also turns, so the sides constantly change direction and temperature. This change could be detrimental because it slightly pushes Apophis toward Earth. Unfortunately, nobody knows how the Yarkovsky effect will influence the asteroid's path. On the other hand, on the asteroid's last flyby of Earth in 2021, Astronomers used radar to take accurate measurements of its trajectory and confidently concluded Apophis will safely miss Earth in 2029 by about 20,000 miles and won't bother us again for at least 100 years. Now, generally speaking, every 8,000 years, our planet is hit by a falling star that has similar dimensions to those of Apophis. The last time we were hit by a slightly smaller meteor was in 2013. A new spacecraft developed by NASA called the OSIRIS-REx was launched in 2016 to collect samples from another slightly less terrifying celestial body called Bennu. 4 years later, it finally arrived at the thing, got some samples, quickly said goodbye to Bennu, and started traveling back towards Earth. The samples were safely stored in a capsule dropped in Utah. So far, this has been the most significant sample ever taken from an asteroid. After the delivery, the spacecraft didn't waste any time and started chasing Apophis. Now, OSIRIS-REx has been renamed to OSIRIS-APEX, and is currently playing tag with Apophis. With some luck, on the 2nd of April 2029, when the asteroid zips close by Earth, the spacecraft will reach Apophis and land on it. It will stay on Apophis for 18 months, collecting valuable information and taking thousands of pictures. The asteroid will be monitored with the help of powerful telescopes. At some point, Apophis will get too close to the Sun, and then all the monitoring work will be on Osiris's apex back. If you live in Europe, West Asia, or Africa, you're one of those lucky people who will have a once-in-a-lifetime opportunity to see Apophis with the unaided eye. It'll be visible in the sky in these regions in 2029, and those who have telescopes will be able to spot it once again in 2036. OSIRIS-APEX will experience some problems because the asteroid has a thick crust, and the spacecraft won't be able to collect data as easily as it did with Bennu. OSIRIS-APEX has a unique thruster that will blow all the dust from Apophis while landing. This will be a perfect chance to analyze the surface of the asteroid to see what it's made of. The craft will spend 1.5 years mapping the asteroid, trying to detect changes in its shape. All this research will show how the celestial body is likely to move so we can better design plans to protect Earth from such things. In 2025, NASA is also going to launch the mission Apophis Pathfinder, and it will be the first spaceship to ever touch this asteroid. It will land approximately a year after its launch. Also, NASA has proposed sending a swarm of tiny craft into space to help humanity develop effective protective tactics against asteroid strikes. We know that Apophis originated in the primary asteroid belt between Mars and Jupiter. In the past million years, this celestial body has changed its path because of the considerable influence of Jupiter's gravitation. Now it seems like it favors the Sun more, meaning this asteroid will come very close to Earth. That's why it's classified as a near-Earth celestial body. A lot of tests and research have been done to find a way to deal with asteroids. Some solutions include drilling and detonating the space body from inside, or testing new technologies, like attaching rockets to it and trying to steer it away from Earth. We can also hit it with something moving at high speeds to make it change its course. Apophis is an S-type asteroid made of rocks and minerals like iron and nickel, and is shaped like a peanut. It can tell us a lot about the past and possibly the future. Sampling this space object could reveal how life on Earth began and how plants appeared. There are many theories that suggest that water arrived on our planet on an asteroid or a comet. Asteroids are like priceless time capsules. Unlike rocks on Earth, which have undergone thousands of changes, like erosion, most celestial bodies are still intact and much easier to study. When meteors fall on Earth, they get covered in debris that's impossible to clean. That's why studying Apophis while it's still in space is so important. Also, some asteroids are made of precious metals like platinum. Right now, we have a high demand for metals that we use in production, and mining metals on Earth is quite tricky. Just one large meteor might have iron, nickel, gold, and platinum that could last us millions of years. If Apophis has this amount of metals, Well, we'd want to break it down and bring it back to Earth. One space rock could be worth quadrillions of dollars, making space mining highly profitable. And still, it would cost us more to get it back to Earth than to dig up these materials here. As technology progresses and new kinds of rockets are developed, this might become possible at some point. So, even though we're safe for the next 100 years from Apophis, you probably still want to see what would happen if something like it did impact. Come on, sure you do. Well, first let me tell you, you'll hear the sound of the collision and know what's happened even if you're miles away. You should leave your house or apartment immediately. Shortly after the impact, massive earthquakes will strike, and many tall buildings will fall. So, staying away from cities might be your best option if you have a choice. But don't escape by car. There will be massive traffic jams, and everyone will panic. Going on foot or by bike is your best option in this scenario. A prime way of transportation will be traveling by plane. So, if you've always wanted to get that pilot license, now you've got a good excuse. If you have time, take along extra snacks and water, and an extra pair of socks. It's nice to live by the ocean or the sea, but in this scenario, it's the worst place to be, because giant tsunami waves will hit coastlines after the impact. If you live far away from the impact area, the tsunami might take 30 hours to arrive. You'll have a bit of time to prepare,